Hi students, in this video we're going to look at how to calculate the area between two curves. Alright, so what you should be able to do after watching this video is calculate the area between curves both with and without technology. Big thing to remember, again since fundamental theorem of calculus, area is calculated by determining the antiderivative, substituting in the endpoints of the interval and subtracting them. And you also need to remember your integration rules, depending on what functions you have and how to calculate those areas. Right, so what we want to do is consider how can we find the area between these two graphs, between red and green. Well, if you stop and think about it, it doesn't end up being too difficult, because we can find the area underneath the red curve. Let's call the red curve, oh I don't know, let's call it f of x. So the integral of f of x dx will give us the area under the red curve. Then if we take away the area underneath the green curve, take away, let's call that one g, that should give us the area in between. The area, that blue area from the top down, subtract away that orange area under, let's call that g of x, and that should give us the area between the two curves. Now the key piece of information that we need before we think about getting that solution is what is our interval. So we will need to work out the intersection points, the intercepts of our two graphs, before we consider how to do the integral. So the bounds of our integral, the area between these two curves, will just be the points where our curves intersect. So to determine the area between two curves, f of x and g of x, where f of x is the one is the top curve, so that's what this part over here means. Over here, so f of x is the top, g of x is the bottom curve. There are a couple of steps. First of all, we need to get our interval. Our interval is going to be between the points of intersection. So that's why it's quite important to make sure we find our intersection points first. After that, our second step is to draw a sketch to help if we need to. And then the last step is to use this formula. So to use our integral from a to b, so from our points of intersection, and then the formula is top curve minus bottom curve. And that will give us the area between our two functions. Alright, so let's give that a go then. We've got our two functions here. We've got f of x plus 10, and g of x is negative x squared plus 16. Now, we've got a sketch here for us. Key thing to notice, students, is that this second one is our top curve, and f of x in this case is actually our bottom curve. So even though it's a bit different to the notation we had in our previous example, the key language is top and bottom. So the parabola is the top function in this case, and the line is the bottom function. Now, our first step is to work out our intercepts, so we need to solve these equations simultaneously. So to do that, we'll just set those as equal, plus 10 to equal negative x squared plus 5x plus 16. I'm going to rearrange everything to the left because I don't like having a negative coefficient of x squared. So x squared will then have 4x minus 5x, that'll be negative x, and then 10 minus 16, that'll be negative 6, equals 0. Alright, from there, well, it's a quadratic, and I can factorize that. That'll be x minus 3, x plus 2, equals 0. So x is going to equal negative 2 or positive 3. And so that's going to be the bounds of my integration. So I think I'm going to need a bit more space to solve this problem. So what I'm going to do is just write those values up here, and we will get rid of all of this so we can have space to solve the rest of this problem. Alright, so our area is going to be equal to our integral from -2 to 3. Now our top curve was -x squared plus 5x plus 16. Subtract our bottom curve, 4x plus 10 dx. Simplifying that, it becomes our integral of -2 to 3 of -x squared plus x plus 6 dx, which equals integral from well, it's not really an integral anymore, we can integrate that, it'll be -x cubed on 3 plus x squared on 2 plus 6x between 3 and -2. That's going to equal -3 cubed on 3 plus 3 squared on 2 plus 6 times 3 minus negative of -2 cubed on 3 plus x plus -2 squared on 2 plus 6 times -2. Alright, so doing a bit of work here, so that'll become -9. -9, 3 squared on 2, that'll become plus 9 on 2. 6 times 3 is 18. Subtract. -2 cubed is -8. That negative at the front will make it a positive, and then minus that. So minus 8 on 3. -2 squared is 4. 4 over 2 is -2. And then 6 times -2 is -12. But that negative out the front makes it plus 12. Alright, so all put together, we will have, that's a good question. So we will end up with, I'm just going to do the whole numbers and fractions separate, and then we'll tie it all together at the end. I think, so -9 and 18 is -9. Sorry, +9 minus 2 is 7. Plus 12 is 19. And then 9 on 2 minus 8 on 3. So 9 on 2 is going to be 27 on 6. And 8 on 3 is going to be 16 on 6. So that'll be 9 and 11 sixths. 19 and 11 sixths. Simplifying that a bit further, 11 sixths is 1 and 5 sixths, so that'll be 20 and 5 sixths, or 125 over 6 is the area between those two curves. Right, so after watching this video, students, you should be able to calculate the area between two curves with or without technology.